Swayam Prabha. Digital India. Educated India.
So, hello student, today we will extend our discussion on collection of solid waste. So, in the part 1 we have seen the analysis of Hall container system, we found some unit operations also and we solved few numericals. Now, this is the part 2 where we will discuss the analysis of stationary collection system. Okay. So, I think see a few slides are similar like why we important to analyze collection system, because of unit time required in the each task is very important, and there are different unit operations that pick up, haul, at site, off route time. So, which we will discuss during the stationary container system or collection system. So, before that we will go one example simple, which was initially also discussed in the previous class, how the operation of stationary container system. So, the route will get start from dispatch center wherever the vehicles are available, or at night wherever they will be dispatched. It will start with the first location and it will load the content from the container from the location, so that the container will be empty. Then it will go to the next location, next pickup location, it will do the same way, it will load the content from the container or dustbin, and you will get one empty container in the same location. Similar way it will go to the different location or nth location, and once the vehicle will get full completely, whether is a simple vehicle or compactor vehicle, and finally it will go to the transfer station, recycling facility or disposal site. And from that, if the time available in a day is available, then it will go to the, it will start the next route. If suppose the time will get over 8 hours, it will go to the dispatch center finally, or otherwise it will start the next collection route, like it will start the beginning, this will be the begin the next collection route, and this is the collection route for one trip. So, now first unit operation will see pickup. So, in this case in stationary container system, pickup refers to the time spent in loading the vehicle, beginning with the stop to load the first container and ending when the last container has been loaded. So, it will start from the first location loading, and it will go to the beginning, and it will the last container loading. So, this entire collection route will have the pickup time. Okay. Now, the next unit operation is a haul. So, here haul, the time required to reach the location where the full container will be emptied and continue until the truck arrives at the location where the first container will be emptied for the next route. So, it will start from the last container location to the recycling facility or disposal facility, and also it will start the time required to go to the next route, next collection route, and is not including the pickup and redeposit of container. Okay. This is the same in the Hall container system. Remaining unit operations are almost similar, which was discussed in the Hall container system, like at site time and off route factor, necessary unnecessary off route factors. Now, we will see the some equations which in stationary container system, which we have seen in the Hall container system. So, first is the, because there will be a two way of stationary container system. One is the mechanically loaded container collection vehicle, where mechanically container is getting loaded onto the vehicle. So, there time per trips will be pickup time plus S plus A plus Bx. It is similar to the hall container system, because entire route time is required, same in the stationary container system and the hall container system. Now, in this pickup time per trip in the hall container system, that was PC plus UC plus DBC, but in this case this will be PSCS, that is stationary container system is CT into UC plus NP minus 1 into DBC, where CT is the number of container emptied per day, and UC, here is the UC is average unloading time per stationary container, NP is the number of container pickup locations per trip into DBC. Here you see that we did it here NP minus 1. Why? The number of container pickup locations per trip minus 1. You see here in the operation. So, operation, if you see here, the number of container locations, suppose these are the 4 container locations, but you see the DBC is 1, 2 and 3, means that will be 4 minus 1, that will be a DBC value. So, that is why we did NP minus 1 into DBC, okay. And UC also has been multiplied to the number of container emptied per day, multiplied by UC value, that unloading time per location. Now, here has to calculate the pickup time depends upon the number of container multiplied by the unit loading time plus the number of locations times the driving time between the locations, that is NP minus 1 into DBC. Now, number of trips per day can be calculated VD divided by VR. ND is the number of collection trips required per day, VD is average daily quantity of waste collected, V is the volume of collection vehicle, R is the compaction ratio. You see here is a very simple equation. Number of trips can be finalized simply if you know the average daily quantity of waste generated and divide by volume of collection vehicle, and that also volume of collection vehicle will be multiplied by compaction ratio. And if you know the average quantity of waste generated or collected onto that particular area, we can calculate number of trips per day. This is easy to remember these formulas. Now, time required per day, that is the H value we can calculate, or is the similar equations if you done in the TSCS form. So, remaining times are other terms are usual, like ND is number of trips, T is the total time, T1 is time to drive from dispatch station to the location of first container, and T2 is time drive from the approximate location to the last container to the next route. And now, here few equations for manually loaded collection vehicle, that NP we can calculate by 60 into PSCS N divided by TP is also simple expression for NP value, where number of pickup locations we can finalize by pickup time multiplied by number of collectors or how many laborers are working. And if you know the TP value like pickup time per pickup location, based on that we can calculate number of pickup locations, and this multiplication also this 60 is because if you see the unit of TP is collector minute per location, that is only the conversion factor from hour to minute. Now, the TP has to be calculated, the pickup time, that is TP per location depends on the time required to drive between container location, that is a one point, and the number of containers per pickup location and the percent of rear of house pickup location. So, the formula will go TP is equal to DBC plus K1 into Cn plus K2 into PRH. So, where Cn is the average number of container each pickup location, and PRH is rear of house pickup location, and K1 and K2 are constants related to time required to waste collect from the either per container or from the backyard of the residence in the PRH. So, by that way we can calculate the TP value. Now, we will go for problem. Here we will solve the two problem by giving the different operations. So, the first is a problem statement is we have to design the solid waste curb collection system to service a residential area of 1000 single family dwellings, and two manually loaded collection system are to evaluated. That is, first involved the use of single loaded collection vehicle in a one person crew, that is the first choice or first collection system, and second is the second involves the use of rear loaded collection vehicle with a two person crew. So, we have to compare the both collection system which will be the beneficial. So, we have to determine the size of collection vehicle required and compare the labor requirement for each collection system. So, we have to compare one person crew and two person crew collection system which will be the beneficial, and some data will be given in the problem. These are the data like average number of residents per service 3.5. So, number of houses are 1000 and the average number of residents per service is 3.5. Solid waste generation rate per capita 1.13 kg per capita per day is very high. Maybe this data is from Japan or some developing countries. Density of solid waste, this is very low compared to Indian waste density, that is 119 kg per meter cube. Container per service. So, there are two containers of 1 to 1 liter plus 1.5 cardboard container, each of 75 liter on average. So, it is having 3.5 containers, okay. And collection frequency once per week, collection vehicle compaction ratio 2.5, means the vehicle is a compactor vehicle, round trip haul distance 56 kilometer. So, x value is given here, this is the x value. Nominal length of work day H is 8 hour, trips per day ND is fixed 2, T1 value is given 0.3 hour, T2 0.4 hour, off route factor is 0.15, haul time constants are given, at site time is given, and the DBC value is given 0.72 hour per trip, this is hour per trip, and constant related to pickup K1 and K2 is given. So, now we will go for solution. The first we will determine the time available for the pickup location. Okay. So, that is H. By this formula we can calculate, where we know the ND value, but we do not know the PSCS value. So, from this we can calculate the pickup time for stationary container system. So, the PSCS will come up in this way, and already the data are given like H is 8, 1 minus W is 0.15, T1 and T2 0.3, 0.4, S at site time 0.1, and these are the constant A and B, and the X is given 56 and ND is 2. So, by that way we can calculate the pickup time is 2.32 hour per trip. Now, we will determine the pickup time required per pickup location. So, we have two different collection system, for one is one person crew and next is two person crew. In one person crew TP, we will find it from this table. So, is the similar textbooks which I propose for this course. There are two columns is given here, the average number of containers or boxes per pickup location, and in that case what will be the pickup time, that collector minute per location. So, in our case number of containers on each pickup locations are 3.5. So, in that case we can select the second one, 3 or more or unlimited services. In that case your TP value will be 0.92, which we assume. So, it is possible in the exam these values are given, this table are very easy to remember also. So, and this labor requirement is only for one person crew. Please remember this table is only for one person crew. Now, we will go for two person crew, we will solve by the different equation, but for one person crew need not to solve, we can take it from the same table. And just remember that if there are more than 3 containers in each pickup location, then in that case TP value will be 0.92 collector minute per location, and if there are only 1 or 2 location, in that case we can take it 0.5 or 0.6 value, in between value we can take. Now, for 2 person crew, so we have this formula dBc plus K1 into Cn plus K2 into PRH. So, now we will put up the value. So, dBc is 0.72 plus 0.18 Cn. Now, here PRH is 0, there is no rear house locations are not given, okay, in the problem. So, we will take PRH is 0. So, this will be entire value will be 0. So, from that we can calculate. So, here Cn is 3.5 number of containers on each location, 0.72 plus 0.18 multiplied by 3.5. So, the TP value is 1.35 collector minute per location. So, now we calculate the number of pickup locations. So, in one person crew, the here TP value is 0.92 and N is number of crew person, that is 1. So, in that case the value will come 151 locations per trip, and in 2 person crew here N will be 2 and TP will be for 2 person crew. So, in that case it will come 206 locations per trip. Okay. So, you see here the number of pickup location in 1 person crew is less than the 2 person crew. Now, determine the volume of waste generated per pickup location, okay, to calculate the volume of vehicle. So, this volume per week locations, I think we took the per capita generation multiplied by how many number of people are residing in that particular location, 3.5%, and because the once in a week collection, so we will multiply it by 7, that is the quantity of solid waste. We divided by density, density is given 119 kg per meter cube. So, by that way we can calculate the volume per week per location. Here you see that different problem, the different way the volume of waste will be given. Now, in this case here the per capita generation is given and number of residents per locations are given. So, and densities are given. So, sometimes it is possible that directly value is given in meter cube per day. So, we have to just multiply it by number of residents in that particular location multiplied by 7, that is days in a week. So, here we got the volume per week location 0.233 meter cube per location. Now, we will calculate the truck volume. So, for 1 person crew, that is the Vp into Np divided by R. So, is a truck volume, we can calculate from this formula. So, here is a simple volume generated multiplied by number of pickup location and divided by compaction ratio 2.5. So, that is coming out to be around 14 meter cube collection vehicle. So, simple dumper vehicle will have almost size of 18 to 20 meter cube. So, if you have the one vehicle simple dumper vehicle having 18 to 20 meter cube is feasible for this collection system. And if you compare with the 2 person crew, So, in that case is coming out to be 19 meter cube collection vehicle. So, in this case also the similar kind of dumper vehicle could be possible, and if you use the compactor vehicle which can get it which can store or which can load around 130 to 140 meter cube. So, that the same vehicle can be collect the waste from the different locations, because it is a collection once per week is there. So, that is why you are getting this much amount of waste, and if you go daily collection, you need not to multiply it by 7. So, your volume will be very small. So, in that case this value also will be a very smaller value. So, it is possible that the smaller vehicle or one auto tipper having size of 4 meter cube, 5 meter cube is feasible for 1000 households, could be possible. Now, we will calculate the number of trips required per week, because it is a once in a week collection. So, how many trips will be required per week? So, for one person crew that we can do it by number of locations, that is 1000 location divided by how many locations could be possible in each trip. So, by that way we can come up with number of trips required per week, that coming out to be 6.62 trips per week, and 2 person crew, that is coming out to be 4.85 trips per week. So, you see here in 1 person crew we required the more trips per week compared to the 2 person crew. Now, determination of the labor requirement, the means how much time will be required, and here also one important note that even though the partial trip is computed, now here partial trip, because it is not possible to having 0.62, this should be a one single numerical value. So, even though the partial trip is computed, a full trip will have to be made to the location where the content of the collection vehicle will be uploaded. So, it is now it is good to see that if you can get it these trips, we can assume these trips 7 trips per week, and in this case 6 trips per week. By that way we can calculate the how much is the labor requirement. So, and this we can calculate, this is TW is total time per week, how many days will be required, and in this particular collection system, and the unit will be days per week, how many days will be required in a week, that is labor requirement, that we can calculate by number of collectors NW into PSCS plus TW into S plus A plus Bx divided by H into 1 minus W. Here the NW we already calculate, and this TW is a we can put it 7 in the 1 person crew, and in 2 person crew 6 this value. Now, we will calculate the 1 person crew, it is coming out to be 3.01 collector days per week. So, this much days will be required in 1 person crew, and 2 person crew will be required 4.39 collector days per week. So, here we can easily compare that the labor requirement in 1 person crew is a low value compared to the 2 person crew. So, the major comments onto this solution, labor requirement for 1 person crew are approximately 25% less than the corresponding requirement for the 2 person crew. So, that is why the result of this problem illustrate why the trend in the collection is towards to the use of curb collection with a one collector driver and collection vehicle, that is either manually or mechanically loaded, normally we found in the most of the local authorities. Now, there is one more tabulated answer here, the time required for pickup location, that is the same for both the case. So, here TP value, number of pickup locations, so is a very surprising number of pickup locations 151, in this case 206, and required volume is smaller here, required truck volume smaller compared to the 2 person crew, a number of trips is could be possible more here compared to the 2 person crew, and finally, labor requirement also is very less compared to the 2-person crew. So, your answer is the 1-person crew is more beneficial for the stationary container system. Okay. So, now we will go for next problem, where we will compare the ND value ND 2 and 3. So, the problem statement is design of solid waste curb collection system. The similar way 1000 single family dwellings is a manually loaded collection system and having facility of rear loaded collection vehicle facility, and specially here the option is given only the 2-person crew, only one option, and we have to determine the size of collection vehicle required and compare the labor requirement for the following for ND 2 and ND 3. These are the two options are given. Okay. But remember that we have only one choice for person crew is only 2-person crew. Now, we will go for similar way problem solution, and data are given. So, similar data are given. Now, here the one different the PRH values are given, okay. 20% rear of house pickup locations. So, you remember that while calculation of TP value, we need to use that particular equation DBC into K1 into Cn plus K2 into PRH. Now, here 2-person crew. So, we cannot take the values is given in the table from the book. So, we have to analyze by this equation. So, we will start the solution. Similar way we can calculate the time available for pickup operation. First we will go for ND 2. So, here we can calculate the P SCS value, and it will come up to be 2.22 hour per trip, that is for ND 2, and for ND 3 that is coming out to be 1.2 hours per trip. So, you see here for number of trips per day will be required more pickup time, and here pickup time is less here in ND 3. So, is a very obvious answer. Now, we will calculate the pickup time required per pickup location, that is TP value. So, TP value will be now here you see the PRH locations, we took 20%. So, is a 0.2 PRH. So, is coming out to be 1.4 collector minute per location. Now, once the TP is known, that we can calculate number of pickup locations from, that is for trips per day, NP we can calculate. Now, here N is 2, okay, for ND 2. So, both the cases the pickup time is different here, okay, PSCS value. So, in ND 2 it will come out to be 190 locations per trip, and number of trips 3 per day. So, from that we can calculate the number of pickup locations, that is coming out to be 102 locations per trip. So, we can calculate the similar way volume of waste generated per pickup location. Okay. The similar way, the first we can calculate the quantity of waste generation divided by density. So, that is coming out 0.256 meter cube per location. Now, we will calculate the truck volume, the first in for ND 2. So, we can calculate the vehicle volume is coming out to be 16 meter cube collection vehicle, okay. And for ND 3 8.7 meter cube per trip, we can use 9 meter cube collection vehicle. Now, here you see that for ND 2 required larger size vehicle, that is 16 meter cube size vehicle will be required, and if you go for ND3 number of trips per day 3, then in that case will be required smaller size collection vehicle. Now, we can calculate the number of trips required per week, that is NW value. So, the total locations per week and the number of pickup locations. For ND2 5.26 trips per week is coming out, and for ND3 9.8 trips per week. So, from that we can calculate the labor requirement. In that case, we can take this value 5 and this we can take 10. So, the same way the full trip has to be made in the location. So, we can calculate by the similar formula. For ND2 is coming out to be 4.9 collector days per week, and for ND3 is coming out to be 5.9 days per week. So, here you see for ND2 will be required 4.9 days per week, and for ND3 5.9 days per week. So, your answer will be the ND2. So, in that case, so it is required lower time as compared to the ND3. So, we will go for tabulated comparison. So, in that case you see here pickup operation required different values. So, the large value in the ND2, number of pickup locations are more here in ND2 compared to ND3, and finally, your vehicle size is large compared to ND3, and number of trips but lower here compared to the ND3, but if you see the labor requirement or time required in a week, that is low compared to the ND3. So, here answer is now ND2 is your answer. Okay. So, during this class we understood how to solve the problem related to stationary container system. Here we took two different examples. One example was given the two alternates, 1 person crew and 2 person crew, and next problem the second problem was given where two alternate was given ND2 and ND3. Similar way it is possible that and we can compare the different alternatives, and based on that we can finalize the more beneficial solution by comparing with the vehicle volume and labor requirement. Based on that we can select one particular option or particular alternates. So, now next lecture we will again compare, because now here what we have done from last two lectures. The first lecture we understood the design of Hall container system. This lecture we understood the stationary container system, how the alternates can be compared, but we do not compare whether in the same location it is possible that Hall container could be beneficial or could be possible stationary container system, and that is again depend upon the x value, round trip haul distance, and obviously is depend upon the economy, the cost of both the collection system. So, next lecture we will compare Hall container system with the stationary container system. We will solve one problem and we will plot the one particular curve where we will compare the Hall container system with the stationary container system. And also need to be discussed once any collection system is finalized, whether is a Hall container system or stationary container system, always need to be finalized the collection route. That is important, especially this collection route is very important for the stationary hall container system, because there are number of haulings. Haulings are more compared to the stationary container system. So, thank you for today's class.